welcome back. Now today we're actually going to have a little revision session on making soluble salts. So Dr. Bourne.
Two methods. First method is using an excess of insoluble solid and acid. The second method is to use an alkali and an acid. This method is a titration method which we're going to deal with separately. So in this video, all we have to focus on is using an excess of insoluble solid plus acid to make your soluble salt.
Oh, sounds very, very straightforward. Now I do have a question for you, Dr. Bourne. In fact, I've got two, but the first one is, why do you use excess solid?
Very important to use excess so that you can be sure that all of the acid has been used up.
Perfect. Now, the second point is, why does it need to be insoluble?
Well, insoluble means, as you know, that it doesn't dissolve in water. And when you add it to the acid initially, it does disappear, but that's because it's reacting with the acid. As soon as all the acid has gone, you'll see the excess solid in the bottom of the beaker.
Perfect. Now, the whole point of this is to make soluble salts. So if we have that excess solid, which is in your beaker, how do you remove it?
Filtration.
Perfect. There's always a solution for every process in chemistry.
Absolutely.
Now, if I look at the insoluble solids that you've mentioned, there's a metal, base and carbonate. Now, does that remind you of any session that you've done, Dr.
Well, it
Bourne?
does remind me, and I hope it reminds you of your general equations, because we learned about metal plus acid, base plus acid, carbonate plus acid.
Excellent. Now, let me just have a look and think. Now, if I wanted to make zinc nitrate, Dr. Bourne, so what would I use?
Right, you have to split up your salt and look at the first part and the second part. Look at the second part of the name first. If it's a nitrate, you're going to use
Nitric acid.
If it's a sulfate, we'll put that in there. Great.
Acid.
So we know for this one we've got nitric acid, and then you've got to think, where will I get the metal from? Now for this one, you've got zinc. Would zinc work on its own?
Yes, I do know zinc reacts with nitric acid, so I could choose zinc.
Perfect. Zinc plus nitric acid gives you zinc nitrate, but it will also give you...
Let me think. I think that was the mash, so that is hydrogen.
Yes, so we mustn't forget to add our hydrogen in. So we'll just put that in.
Excellent. So that's the way to make zinc nitrate. So I could use zinc oxide.
Yes.
I could use zinc carbonate. It will
Yes.
all work out the same.
All right.
Right. So if we're dealing with copper 2 sulfate.
Right, with this one again, look at the end of the salt. If it's a sulfate, you have to use
Sulfuric acid.
sulfuric acid. Lovely. Now, copper 2, what are we going to use for the copper 2?
Ah, I know. Copper.
Now, there's a problem there. Copper is not a very reactive metal, so you've got a difficulty. You can't just use copper.
So that means I would have to think base or the carbonate.
Yes.
So if I use copper 2 oxide, that'll work. Excellent. And I know there's another product because of the word equations you gave me, and I believe it is water.
Yes. Base plus acid, salt plus water.
Excellent. Now the last one, nickel chloride. So if you have actually taught this properly, that means chloride comes from hydrochloric acid.
Excellent. Hydrochloric acid. And then you've got to find your nickel, which might be a metal you don't know very well.
But they try and do that to you, they try and test you. Don't let it confuse you. So I'm going to go, since we've used a base and we've used a metal, I'm going to go for nickel carbonate.
Lovely, because if you're not sure how reactive a substance is, better to go for the base or the carbonate.
And because of the carbonate, I know that water is produced and carbon dioxide.
Lovely. Now there's only other one thing you really need to look out for. If they'd asked, for example, for you to make sodium sulfate, what would the problem be there?
Well, sodium sulfate uses sulfuric acid.
Yep.
You could use sodium.
Ooh, think about that carefully.
Sodium with sulfuric acid. That would work, surely.
Very reactive. Sodium is one of our more reactive metals, so if you add it straight to an acid, you've got problems. You cannot use sodium with an acid directly.
Because it's too reactive.
Too reactive.
And the other thing is, sodium does react with water, so it wouldn't be insoluble, it would react with the water.
Yes, because if you remember, sodium is, I've moved on to the spar salts here. So I'm thinking about our spar salts, you remember those?
Oh yes, the
So
spa salts.
They're all soluble, so you can't use the base or the carbonate either.
Ah, right. So if any of the metal or the base or the carbonate is a spa, then you do not use them. So for example, sodium oxide, potassium oxide or ammonium carbonate you don't use.
No, different method.
So as long as we remember that, this method will work.
Always.
Excellent. So, hashtag job
Job done.
done.